All right, hi guys. My name is Annamarie Clobuciar, and I'm going to be helping you figure out the rule of 68, 95, and 99.7 for Math 125 Statistics Unit. So I know that many Math 125 students as of right now are in the Stats Unit, and I feel like this is a really big and important concept to understand because it kind of follows you throughout the unit in different ways. So for starters, I'm going to fill out our wonderful little chart here, and if I have time, I will go through some examples of how to use this graph. So the first thing we'll do is start in the center, which is 0. And as you can see, there's 3 lines to the left and 3 lines to the right. So our first line to the left would be -1 standard deviations. Our second line to the left is -2 standard deviations. And our third line to the left is -3 standard deviations. So that means that our left half is going to mirror our right half, and we're going to have 1 standard deviation, 2, and then 3. So the next thing we really have to figure out is, what does this mean in terms of our percentages? Because we know that we have a line that's our 0, and we have -1, 2, and 3, and +1, 2, and 3. So the first thing I'm going to do is connect our first set of standard deviations, which is 1 standard deviation to the left and 1 to the right. Now, this would be our 68 and our rule of 68, 95, and 99.7. So then if we go up to 2 standard deviations to the left and 2 to the right, we will get our 95. And if we go all the way up to the third, then we'll have our 99.7. So I'm not sure if you guys know this, but this chart is out of 100. So in order for me to show you that, I'm now going to fill in the different percentages on each side. So if we have 68 broken up over 2 areas, 68 divided by 2 is 34. So that means from 0 to -1, we have 34%. And the same goes for the other side as well. So I'm just going to kind of alternate the percentages just so everything doesn't get so jumbled. But what we do in order to find the next percentage is we would take our 95% and subtract it by our 68%, and then divide that by 2. And you'll notice that we would get a difference of 27%, and half that 27% would be 13.5. So that's our next percentage between 1 and 2 standard deviations, or -1 and -2 standard deviations. And then for the third one, we would do the same thing. So we would do 99.7% minus 95%, and you'll notice that we have a difference of 4.7%. So we would take that 4.7 and divide it by 2, and then from -2 to -3 standard deviations, or +2 to +3 standard deviations, we end up getting 2.35%. So now you're wondering, well, if our chart's out of 100, why do we only go up to 99.7%? And that's because outside of our little curve in our standard deviations, there's 0.15% that's not accounted for. So now that we know this, we could do a little example problem. So if I could get this to work, you'll see that I have an example problem here and it has numbers. So in order to answer A, we'll go back up to the problem that I have right here, and it says the distribution of scores on a test is normal with a mean of 72 and a standard deviation of 4. So what I'm going to do is kind of redo these numbers and write below it. And what I'll end up doing is I'm going to put our 72 in the middle, which is where our 0 is. And we know that we have a standard deviation of 4. So that means if we go to the right, we do 72 plus 4, which is 76. And we do 76 plus 4, which is 80. And then we do 80 plus 4, which is 84. So now to figure the numbers out to the left, we do 72 minus 4, which is 68. Then we'll do 68 minus 4, which is 64. And then finally, we'll do 64 minus 4, which is 60. So to show you guys a quick example of how this would work is you might get a question that says, what percentage of students scored between 68 and 78? So we know that we're starting at negative 1 standard deviation, and we're ending at positive 1 standard deviation. So what I like to do is just kind of trace these lines up, and we'll see that when those two are connected, we get 68%. So 68% would be our answer. So then if we had something like, what percentage of students scored between 72 and 76? Well, we know that it's only from 0 to 1 standard deviation. So we would do 68 divided by 2 if we were based off our negative 1 and positive 1 standard deviations. But we already know that from 0 to negative 1 or 0 to positive 1 is 34%. So then our answer would be 34%. So then our next thing is, what percentage of students scored over 72? So let's remember that our chart's out of 100, and our 0 and 72 is right in the middle. So that means everything 72 and above would be 50%. And then I'm just going to do one more, even though I know there's a few more examples. But if you were given a problem that says, how high must a student score to be in the top 2.5%? Well, we know that from 2 to 3 standard deviations is 2.35%. And we know that 3 standard deviations and above is 0.15%. So that gives us our 2.5. So in order for a student to be in that top 2.5%, that means they have to score at least an 80. All right, I hope this video was helpful and it kind of helped you understand how to use the rule of 68, 95, and 99.7 better. If you have any questions on Math 125 statistics, please go to the Learning Center website and look up different tutors who could help you. Have a great day.